Differentiating natural log functions. Okay, so a natural log is basically a log to the base e of any function of x. Okay, of any function of x. Let me just shorten that to ln f of x. And the formula states that you should copy this into the denominator and then differentiate this function of x and put that into the numerator. Okay, so if we differentiate ln x, the f of x, this part, is here. So the formula is telling us to copy that into the denominator there, and then it's saying take your function of x, which is the x, differentiate it. If you differentiate x you get 1, we put that into the numerator. There we go. Example 2, differentiating ln 5x. So the 5x, which is our function of x, goes into the denominator. If we differentiate our function of x, so differentiating 5x will give 5, and then the 5's cancel to give 1 over x. Now with logs, sometimes we can do some initial preparation using the laws of logs and then do the differentiation at the end. So ln 5x, the 5 and the x are multiplied, so I could write this as ln 5 plus ln x using the multiplication rule for logs, and then instead of differentiating ln 5x, I'm going to differentiate these terms. So now I've got d by dx ln 5 plus ln x. Now ln 5 is a constant. When you differentiate a constant you get 0. If I differentiate ln x, the x goes into the denominator. Differentiate the x, you get 1. Same answer. Example 3, differentiating a natural log. So we'll get a fraction. Our function of x is 3x squared plus 1, and we copy that into the denominator. 3x squared plus 1. We differentiate it and put it into the numerator. So if I differentiate 3x squared, I get 6x. If I differentiate 1, I get 0. So here's the final answer. Differentiating ln of this fraction here. So here's the long way, and I wouldn't do it this way. So my f of x this time, so in the formula this part is actually all of this. So if I copy that into the denominator here, so then this goes into the denominator, and then I'm going to try and work out some way of differentiating this highlighted part in green and then putting the result here, and it's too long a method. An easier way would be to use some of the laws of logs to simplify first, to simplify this, and then to do the differentiation. Okay, so I have a single log term here, so using the division rule for logs I can write this as ln, and the 6 plus 4x from the numerator goes here. The 3 minus 2x in the denominator will give me a negative log term, and then 3 minus 2x. So instead of differentiating the left hand side, I'm going to differentiate the right hand side where I have two separate log terms and there are no more fractions, so considerably easier. So differentiating my first log term here, the f of x will be the 6 plus 4x, so that will go into the denominator. I differentiate my function of x here, the constant gives nothing, the 4x gives 4, so that's now done. Moving on to my second log term, this time my f of x is 3 minus 2x, so that will go into the denominator. I differentiate 3, it gives me 0, differentiate minus 2x, I get minus 2. Now there was a minus in between the terms, I'll put that here, and we can see that minus and that minus can cancel, like so. And we can see these are all multiples of 2, so we can cancel these down, like so. So the derivative of ln, 6 plus 4x over 3 minus 2x, is given by these two fractions. For practice, try these questions.